Hi everyone. As we had discussed in the previous two videos, that in the first video we set it up the EBGP based underlay, and in the second video we did the OSPF based underlay and IBGP overlay. And as I had said that the next video we will do will be the bridged overlay, the actual EVPN-VXLAN into action. So for that one, what I've done here, that we'll be using this QFX as servers. If I just show you the configuration here, it's a pretty simple configuration. It's just the routing instances. Show routing instances, display set. So I've just set up these routing instances with server 1 with router with interface 1, server 2 with interface 2, and so on. And actually what I've tried is that interface 1 is on the same range as interface 3, and interface 5 is the same range on the interface 7, and 2 is on the same range as 4, and 6 and 8 should be on the same range. Just that once we are connecting them to different switches, so the same VNI extension could make them connect to each other. And if I want to show you the interfaces, so you will have the idea. So this is 1, so interface 1 and 3 are on the same range, 2 and 4 are on the same range, 3 and 5 and 7 are on the same range, and 6 and 8 are on the same range. So but if you want to see that how they are, at the moment I've not done the connections, so just for you to understand, if I say run ping, so this is in routing instance SRV1. So in SRV1 it's pinging it, but if I do it on SRV2, which is on a different routing instance, there's no route about it. So you people know that how routing instances work. I mean, if you don't know, maybe you can comment it and I can try to do a small video on that, but it's pretty much it. It's not much difficult or different. All right, so for in this video I'll just be doing the a bridged overlay, I mean just an L2 extension, nothing funny. And just to make the video a little better, I have done the configuration already here. So if you say show protocol EVPN, actually it's just these two lines, show switching options, so it's these two lines. And the VRF target auto is something which is going to work for automatically create the export and import route targets. That's why we don't have to do the communities and create the policies where we call in the communities and then we are doing the import based on that one. In this video we'll just do it on auto, and in the next video we'll do some play arounds. So leaf 1 is configured, leaf 2 is also configured. If I may show you, show protocol EVPN, so and show switching options, so it's also configured. And just to give you the idea, I'm gonna do this configuration on leaf 3. So set protocols EVPN, encapsulation is VXLAN, and in EVPN we have the encapsulation MPLS also, but that's a different topic altogether. And extended VNI option, VNI list, we are taking it as all. We have a capability where we can do per VNI lists. All right, and then is set switching options. And the VTEP source interface is loop 00, And once you do that, you must check that in your routing options you have set the router ID to be your loopback 0, which I've already set. And after that you will do route distinguisher, which is pretty much the IP address with another value of a colon. You can do it with your autonomous system number. You can just do it colon 1 or whatever value you want to give it. And the VRF target. So if you could see the AS number is 65400, so I'm doing that one. And here is a command which is actually going to take care of import export. With that one, we have to create a VLAN. I'm at the moment taking as a VLAN ID is 10. Now with this one, because you are doing the VXLAN and VXLAN is starting from your VLAN, so you bring in the keyword of VLAN and you have a VNI. That's your virtual network identifier. That's it. So this is a pretty basic configuration for doing EVPN VXLAN. You have your protocol EVPN, you have your switching options, and with the VLAN you have a VNI, and that's it. Alright, so in the start of the video I showed you the it's another other vQFX. If you see this one, run show version, it's a vQFX, and I have just created some multiple routing instances on that. And I showed you here that instance 1 can ping it, and instance 3 is on the same range, but there's no communication between those because they are on two different routing instances. And at the moment I have not done the connection, so let's do the connections. So in here, XE01 is routing instance 1, so you bring XE01, and in here XE02 you can connect it here, save. I'm using the licensed version of EVNG because if you're using the community version, you cannot do the connections while the devices are working. So that's a bit of a perk I have. And XE03, because they are in the same IP range, and I'm connecting it to 02 here. Alright, so because this is a simulated environment, and it's gonna work pretty much the same. I mean, if you're configuring the interface where a server is connecting to be a trunk, in that case it should be expecting the VLAN tags while coming in. So in that case we will have to go on the other side and we'll have to configure that as a VLAN tagging, and then maybe configure a unit where the VLAN tag is coming in. But for this one we are just going to do it pretty straightforward, just as an access port. So while we have done the VXLAN, let's see that we should be looking at some routes in the VXLAN table, and actually it's just the connected routes within the fabric. And you can see it here also, run show route. You again have 10, 14, 16, 18, 12, 16, 18, 20. Actually it's These are the VXLAN routes you will see here. Okay. All right, so let's go and configure the port. And if you remember, we had done the OSPF configuration, and that's very well there. Show protocol OSPF is very well working. And if I say show protocol BGP, we had the group underlay deactivated. So what I'm gonna do is I'll say delete or I'll say deactivate protocols OSPF and activate protocol BGP group underlay, just to bring BGP back. Deactivate protocol OSPF, activate protocol BGP group underlay. I'm trying to doing it pretty quick. Protocol OSPF, activate protocol BGP group underlay. So because I just deactivated OSPF, it will take a while for the whole thing to converge. All right, and meantime we can do the configuration. So in here, if we show interface XE002, so there is no configuration. So I'll do what? Just plain and simple set the interface to the access port with the VLAN where you have got your VXLAN tied. So if you do show VLANs, I have a VLAN ID 10 and the VNI is 510. I think I made a mistake. On the other side, I made a VNI to be 5010. So I'll say edit VLANs and replace patron 510 with 5010. Set interface XE002.0 family Ethernet switching. Interface mode, it's a very important that you have to specify interface mode access and VLAN members V10. That's it. So what I've changed is well, this was like a typo already there. So what I'm doing, I'm just giving a port to a VLAN, and that VLAN has got a VXLAN. That's the thing. That's it. And let's go to 3 and let's see the VLAN. So in here you got 5010, it's the right one. So do and check for the interface, show interface XE002, no configuration, set interface XE002, set it to access mode, and the VLAN member is V10. That's all. Okay, and we had done a quick switch from OSPF to BGP. So let's check. Run show BGP summary. Wow. Okay, you have it. You have your underlay established, and you have your overlay established, and you are getting some routes in your default switch EVPN. All right. So with that one, what is the expectation? What I told you was that on this one, if you see, I'll say show route table SRV 1.inet.0. So in SRV1 we have a interface which is XE01 and the IP address is this and the subnet is this. Alright, so check for SRV3, and SRV3 is actually on the same subnet. It's a different interface. Now if we see here, you have got your X03 connected to spine 3, you got your X001 connected to spine 1, and so let's try. We do see this, we do see this. So if our setup is working, we should be able to ping from this IP to this IP. So let's try. I'll say ping 10.0.1.1 as routing instance SRV1. Definitely it's gonna ping for within the routing instance, and if it is 1.3 and the routing instance is 3, this is also pinging, and lo and behold, let's try for this thing, and voila, it's pinging. You are making a ping from server number 3 to server number 1, where your connectivity is from spine 3 to spine 1. Now let's go and check some stuff here. Alright, so if I say run show Ethernet switching table, and VLAN ID was our VLAN ID was 10, and look man, something is happening here. On VLAN 10 you have learned a MAC address over a VTEP, virtual tunnel endpoint, VXLAN tunnel endpoint, and you have learned this address from source is 192.168.100.11, and this 100.11 is this machine. Look again. And you have learned another MAC address on your XE002. And if you do another command, if you say run show Ethernet switching table, Ethernet switching VXLAN tunnel endpoint, what is the source? You are sourcing it. This is your source VTEP IP, this is your VNI ID, and this is your bridge domain, this is your VLAN name, and this is your VLAN ID. Okay. One more thing we need to keep in mind is that the VLAN tag is not taken to the data which is moving from one leaf to the other leaf. So just if you come here, you do a ping, leave it that side, and come back to come back to this side, and in here you say edit VLANs, and you say set v10 VLAN ID 20 show. So now you have changed the VLAN ID to 20, but the VNI is same. Remind it. So you can see that the ping is still going on here. So we'll do commit and come to this side. On the background you can see that the commit is happening, and on here we are looking that the ping is still going on. Commit has happened and we don't see any interruption in our ping because the VLAN ID is locally important, not on the other side. The extension of what is important is VNI. If we change the VNI numbers, that's going to make a problem. And I'll do a rollback one just to make things be looking a bit easier, not confusing. So you can see that what matters is the VNI number, not the VLAN number. This was a small thing what we have done in a bridged overlay. So you can see that on this box we have got two routing instances. One routing instance is given to one routing instance has got XE003, another routing instance has got XE001, and they are communicating from here to here to here, coming back, and this. And actually, as I had said, that this EVPN VXLAN is just gonna convert the whole thing in a big switch, and the propagation of the learned MAC addresses is done via BGP instead of the standard L2 protocols like STP or that kind of thing. Now come back and try to see some routing and try to see some stuff which is happening behind the scene. So look at here, this is our standard routing table, INET 0, VXLAN 0, and now here is the bgp.evpn.0. This is the routing table which is carrying the information of the MACs learned on different sides. So you can see that there is a type 2 is always a MAC route. So the first thing is your route type, and then after the route type, here comes your route distinguisher, here comes your VNI, and here comes the learn MAC. So you can see that the VTAP is sending on a VNI a MAC address, and this is keep a look at this. So it's 94007. So I'll say okay, so in here you see the Ethernet switching table, and you're learning 94007 from 192.168.100.11, and that's the indication here. And you have another route of the same type. It's from your side on this VNI, this, but you are advertising it because 13.1 is 100.13:1 is your route distinguisher. If you come back here, 94.0F, it's you. You means the third leaf device, and type 3 route is basically the it tells you that which is the identification of the leaf device. Alright, so with that one I can just go and I can try to show you the same thing on the other side. you can do run show route table default switch EVPN.0 or default yeah, it's the other table name is just a minute. So yeah, it's here, bgp.evpn.0 or default switch. Basically it's the same routing table. Okay, so in here this 07 is your local route because it's your locally learned MAC, and this thing 0940F you are learning from the other side. Alright guys, with that one I think I've taken too much of your time, and I'll stop the video here, and